Okay, good morning. Let's go through the homework solutions from Tuesday's homework. So to start with, they were all questions on relative frequency and fairness and bias. So for question 1, we were told that a coin was flipped 500 times. So that's going to be my total. And it lands on tails 275 times. That's the frequency of tails. And straight away, before we even look at what they ask us to do, we can work out that the rest of the time it must have landed on heads because there's only two sides to a coin. So that is 225. You can use your calculator to do that if you can't do it in your head. So let's look at the questions. What is the relative frequency? The relative frequency of getting tails. And so that's the frequency of getting tails, 275, divided by the total number of trials. Now we wouldn't leave it like that. We'd simplify the fraction. We can write it as a fraction in its lowest form. And we've got 275 out of 500. And we get 11 out of 20. 11 out of 20. And you know what? It's actually useful to maybe change this to a decimal. In fact, it changes to a decimal exactly. It's not a recurring decimal, 0.55. The second question was, do we think this coin is fair? Is it fair? Well, the probability of getting tails on a fair coin is a half, or 0.5. And 11/20ths, or 0.55, is really close to a half. So we would say, yes, I think this coin is fair. As the relative frequency is close to 1/2, or 0.5. It's close to it. For the number of trials that we have, we would consider 0.55 to be close enough, and we would conclude that this coin is fair, not biased. So we think this coin is, as the question said, unbiased, but fair and unbiased mean the same thing, so you would get full marks for that. Now, let's look at question 2. A die is rolled 800 times. So 800 times is my total. That's going to be the number that goes on the bottom whenever I'm calculating relative frequency. And the number 2 appears 300 times. So that's the frequency of 2, 300 times. Is the die unbiased? Well, let's work out the relative frequency of rolling a 2 is the frequency, 300, the number of times I got a 2, divided by the total, 800. So that's 3/8 as a fraction. But when we're examining fairness, it's easier if we change these to decimals, because it's easier to compare decimals than it is fractions. So 3/8 as a decimal is 0.375. And what do we want to compare that to? We need to compare it to the probability of getting 2 on a fair die. The probability of getting 2 on a fair die is 1 in 6, and as a decimal, that's approximately 0.17. So do we think those two numbers are close together? I would hope that you would all conclude that no, they're not close values at all. This is 37% and this is 17%. So I would conclude that this die is biased, or loaded, as the book told us was another word for it. Conclude that this die is biased because the relative frequency The relative frequency of 2 is very different from the actual probability. So the actual probability is a sixth, and the relative frequency is 0.3738, and those are very different values. So 2 is coming up way more often than we would expect if the die was unbiased. Next, we had question 3, and there was a diagram shown in the book with 4 segments drawn in, and 3 of them were shaded in red. It's going to be pink because that's the pen color I have, and 1 of them was shaded in blue. One of them was shaded in blue, like this. So they asked us, what color would you predict the spinner is more likely to land on? And hopefully everybody can see there that because 3 of the 4 segments are red, we would predict it's more likely to land on red than blue. And give a reason for our answer, because 3 out of the 4 sections are shaded red, or more of the area is shaded red than is blue, anything like that. If you're not sure if your answer is acceptable, just leave it as a comment in Google Classroom and I'll let you know if you're not sure. But any reasonable answer there to explain that more of it is shaded in red than blue, so it's more likely to land on red than blue. Explain how you would change the colours on the spinner so that each colour is equally likely to occur. So fairly straightforward, change one of the red segments, or red quarters you could even call them, one of the red sections to blue. Then each colour will have 2 of the 4 sections shaded in. So there'd be 2/4 would be red and 2/4 would be blue, which means there's a half probability of each of them coming up. Okay, so I hope question 3 was accessible to everybody, that everybody was able to give an attempt at the answer there. Sort of common sense, but sometimes those questions confuse people because they're not quite sure what kind of answer is being expected. Now, and let's look at question 4, which I gave you as well. And they're talking about our standard pack of cards. So you might have had to turn in your book to the page where the standard deck of cards is. They said that a card is picked from random and a red card is picked 11 times out of 20. So the relative frequency of the red card was 11 out of 20. So we had 11 red and we had 9 black. Joe argues that this proves that the deck of cards is fair, and Aoife disagrees. Who do you think is right, and explain your choice? So the question here is, does it seem like picking a red card is going to happen half the time based on the relative frequency? Let's look at the probability. So the probability of getting a red card in a fair deck of cards is 26 out of the 52 cards are red, or you could also say half of them are red. So there's a 0.5 probability. And the relative frequency was 11 out of 20, which is 0.55. And this is identical to the coin toss situation. So we would say that the relative frequency is close to the true probability, It's close to a half. So therefore, we would conclude that the deck of cards is fair. And who would we agree with? And agree with Joe. To agree with Joe. Okay, so that's relative frequency and fairness. Now, today, after you've corrected your homework, I don't want to do, there's one new thing left to do in probability, but I don't want to move on to it today. I want you to practice a little bit more before we do something new. So I'll be putting up some exercises in Google Classroom for you to do, and tomorrow we'll do some new notes. Okay, thank you.